In 1623, the same year Shakespeare's first folio was published, Ben Jonson's library burned down. To express his rage on this event, Jonson wrote a poem, an execration upon Vulcan, cursing and blaming the fire god Vulcan for the fire that took his library. In sections of this poem, Jonson mentioned the Rosy Cross. This is not the first time he mentioned this elusive brotherhood. He also mentioned Kabbalah, a set of steganography cryptographic techniques. He also used the word serious follies, and most importantly he say, and has false stamped there, passes of a play. This could refer to the false ink spots, dotted with a sharp tool inside the printed O's. I will explain. In Renaissance printing, it was very common that dirt and dust from the paper got stuck on the types of text. This dirt absorbed ink and produced small ink blots in and around characters when printing. When the typeset got too dirty, the printer washed the types, inked them again, and continued printing. In this way, ink spots can be seen in some prints, but not others of the same book. Usually dirt clustered to the same areas around a certain type, and ink spots thus appeared roughly in the same place. As we can see to the left, all types of characters could accumulate this type of dirt. In many cases, it looks as if the spot had been deliberately dotted with a tool. This is how sharp ink blots can look, though created unintentionally by the printing process. When thinking about it, it is possible and easy to cloak a binary system among these ink blots. In my investigation of the sonnets, I have collected seemingly repeated instructions where usage of the metaphors eye, sun and gold, among other things, points to O's with one dot. We should thus investigate O's. We find that there exists in the publication O's with no ink blots, with one ink blot of various design and thickness, with more than one ink blot, mostly two. To be able to insert a binary system using ink blots, one could only use the method of adding artificial ink blots. It is of course impossible to delete an ink blot created naturally by the printing process. Thus, if we are looking for one dotted O's, then O's with no dots and O's with more than one dot are uninteresting. We can in this way create a binary system, 0 and 1. In the encryption process, if the encryptor needed to define an O as a 1, he would first check if the printing process created a dot in it. If not, he would add a dot with a sharp tool dipped in ink. If an O needed to be a 0, but the printing process created one dot in it, then the encryptor just add a second dot and transform the O to a 0. A very simple and straightforward process. In the next section further down, we shall see that the encryption of the sonnets can be done very quickly with this method, where only a few sonnets needed to be checked for correct dotted O's.
During my extensive archive investigation of drilled rocks in 2013 and 2014, I discovered that Oak Island contained rocks and boulders with many types of holes, bolts and other metal objects attached. Many of these rocks are likely remnants from 19th century excavation attempts, but others are original work. The metaphor of the dotted O's have likely been used when creating drilled rocks of original work. One dotted O's represent drilled rocks with one hole, but only 3 are to be used with a map. There also exist on the island drilled rocks with 2 holes. If these rocks are original work, then they could be interpreted as mirroring the binary system used in the sonnet's quarto 1609. The 2-hole rocks look like O's with 2 print dirt spots, an invalid reference point if you understand how to read the binary system.
But how should we collect one-dotted O's? What type of system should we use? If we remember sonnet 126, which is 2 times 63, we have a peculiar last section. Her quietus is to render thee, then 4 brackets. Do we need to render the lines in the sonnets? Do we need to read each line and somehow extract the positions of one-dotted O's? Let's check other instructions we have found. If we remember the 4 occurrences of the word audit in the publication, and instructions surrounding these words, then we can suspect we need to count O's and somehow sum them up. The word sum is also mentioned in sonnet 2. The section in Asmund and Cornelia seem to give clear instructions, and to your audit comes the distract parcels in combined sums. Distract parsers could refer to ink blots inside O's. Then we have the peculiar 10 times structure, where all 8 occurrences of the word 10 are mentioned in the same context. Do we need to sum up 1 dotted O's and then multiply the result with 10? This is the hardest part of the decryption process, to interpret instructions correctly. One cannot know how to do it right without experimentation. The sonnet is probably meant to be decrypted by a team of decryptors working in parallel, making experiments. This would work as a resource test. Bacon probably intended the system to be decrypted by a team from a future government of esoteric training and knowledge. I spent many hours trying to figure this out. Finally I found a method which I could confirm to be correct with an external method to a high degree of certainty. More on this verification process further on. The 30 peculiar dots on the dedication page is the information we need. This is the result we should have after counting 1 dotted O's and then multiply the count with 10. Thus the number of 1 dotted O's we need to collect and count is 3. 3 times 10 is 30. But we still don't know how to collect 1 dotted O's and how to sum them up to get the value of 3. Then we have the 4 occurrences of the word twain in the publication, all mentioning the concept of division and that 2 objects are 1. As a result of my time-consuming experimentation, I understood that this indeed referred to the 2 versions of the sonnets, the William Astley and John Wright. These 2 versions need to be decrypted separately and then be combined. If doing it this way, it is possible to verify the result, as we shall see further on. If I need to count to the value of 3 1-dotted O's using 2 publications, then it's obvious that 2 of the O's need to be in one publication and 1 O in the other for each reference point. If this method were invented by me and not the method intended and constructed by an encryptor, then it is very probable we would not find 3 1-dotted O's when decrypting 2 publications, but instead a value dividable with 2, or none of course. Let me explain. Established Shakespeare scholars agree that the difference between Astley and Wright only lay in the title page. This page has a somewhat different typeset for these 2 publications, but the rest of the publication has identical typesets for Astley and Wright. This would mean that both versions were printed in one go, and that the printer inserted the Astley title page on some of them and Wright on others. Ink dirt thus accumulated inside O's in both versions naturally by the printing process, being cleaned after some prints and then to accumulate again. If the printer had no thought on cloaking a binary system with ink blots, he would not bother to count 1-dotted O's and sort the printed pages in 2 piles, one with 2 1-dotted O's and another with 1. This is obvious. So if looking at 2 different 1-dotted O's in Astley and then checking the same 2 in Wright, it is very likely in a non-encryption situation that we will find the 2 O's in Wright also dotted with 1 dot each, thus a sum of 4. The only situation where this would not be the case is when the printer have cleaned the typeset just before printing the specific Wright we are investigating. But if a cleaning took place just before the specific Wright print, then we would most likely find no dots in either of the 2 O's we are investigating. This might seem complex, but it is actually a very intelligent way of verifying or at least raise suspicion that an encryption have taken place. There are also other ways to verify, which I will explain further down. Summary of instructions. What do we need to collect? A. The O's with 1 blot inside must be summed up. They need to be collected from the lines of text, counted and then applied to the order triangle. B. The collected O's must be multiplied with 10, and the dedication page, which includes 30 dots, give instructions on what result we need to get of this multiplication. Thus we need to find only 3, as 3 times 10 is 30, 1 blotted O's on a position in order to define this position as a valid reference point. 2 or more ink blots is not a valid marker, neither is 0 blots. 1 blot only is the valid number, resembling the alchemical symbol for sun and gold. C. One must use both the William Astley and the John Wright prints of the sonnets, 1 copy of each when collecting. They need to be decrypted separately and then be combined.
This means one of the versions will have 2 one-dotted O's and the other 1 one-dotted O in a valid position, 3 total. D. The system of counting to the value of 3 using 2 versions of the publication enforce a difference between the individual publications used. This gives indication an intended encryption have taken place, as both versions of the publication were printed at the same time using the same frames.
So the next obvious question would be, how do we collect one-dotted O's? What should we use as frames? If we need to collect the O's and then apply them to the audit triangle, we need references to be able to place the collection as intended over the triangle. There are only vague possible instructions in the sonnets hinting towards a method. They can be seen here in the white box. This is possibly an intended feature, forcing a decryptor to exercise his wit and make experiments. O then advance of yours as phraseless hand, whose white weights down the era scale of praise. Take all these similes to your own command. Works under you, and to your audit comes the distract parcels in combined sums. The vacant leaves thy mind imprint will bear, and of this book this learning must thou taste, the wrinkles which thy glass would truly show. Tearing of papers, breaking rings atwain. Of folded schedules she had many a one, which she perused, sighed, tore, and gave the flood. So should we dismount the publication, put the vacant leaves on a table and count the one-dotted O's through the leaves? Should we count all one-dotted O's in any place in each 308 sonnets? It is probable the O's of interest are located on the lines of the triangle and not outside of these, otherwise it would be too abstract and too hard to combine the triangle with the reference points. During the 17th century, when no computers were available, advanced geometry math would have been needed in order to have use of the reference points on Oak Island, if they were not located directly on the triangle lines. You would need to keep track of the positions in relation to the triangle using math. But how do we collect one-dotted O's and apply them to the audit triangle? Could each line be used as frame, where we put all lines of text on top of each other to see on what positions on the line we get 3 one-dotted O's? Maybe, but this method would most likely result in a vast number of dotted O's all over this line, as we have 2,456 lines total in the publication and many O's. The text on a full page cannot be used as a frame, as it is not a constant size object. Some pages have more lines of text than others, and we can thus not know how to attach them to the audit sheet. The only constant size object retaining the same form is the sonnet itself, so this is probably what we need to use. Each sonnet have 14 lines with the same distance between the rows. As a result of time-consuming experimentation, I found out that this is the case. The sonnet itself is the frame to use. All sonnets except one, number 99, have 14 lines with the same row height. Sonnet 99 have 15. But in all sonnets, the left vertical side always has a 90-degree angle lining in relation to the rows of the text, more or less, and all rows are located with the same distance between each other. A perfect frame to use when collecting O's. I found out during decryption that sonnet 99 have a valid reference point 1 dotted O on the second row, seen here in the red ring. Sonnet 126 actually tells us that we should attach the collection frame on the lower 2 lines of each sonnet, and in sonnet 99 the frame should thus be positioned as shown here. The first line in sonnet 99 is thus not used within the frame. This is a feature inserted to confuse, and one must interpret sonnet 126 correctly in order to get it right. I know this is the correct interpretation, as I was able to verify the result externally, but more on this later on. In this visualization we see how exact the frames line up with the lines of text over the audit sheet. All frames here have exactly the same size. When aligning them to the left vertical side of each sonnet, we get a very precise framework. But we need to figure out how to collect the 1 dotted O's, and this turned out to be a tricky enterprise. First I needed to think hard. If I should go through the Aspley and Wright versions collecting one dotted O's from all 308 sonnets, what if some of the same valid points in the sonnet frame hit the ordered triangle lines in different ordered sonnets 4, 5, 15, 16 and 17? This would make it uncertain where the point should be positioned, if not in all places where it hit. The 4 points you see here in the purple circles are points on a frame that hit the triangle in different places, depending on in which sonnet we place the frame. This is an issue we need to address. Does the author intend these kind of positions to be valid in all places, or do we need to collect O's differently for each of the ordered sonnet frames? A complicated question. Let's assume we need to separate the collection areas and define what collection should go to what ordered triangle frame, seen here, and try to figure out the way to separate them. If we look at the ordered lines in a sonnet frame, we see that we have essentially two quite large areas where the reference points could be uncertain. In these areas, the ordered line exists in several of the ordered frames at the same place. If any point is positioned inside the red areas, we will not know what ordered sonnet frame it should be set as a valid point, if not in all of these frames. Thus we cannot know how to place the reference point on the ordered triangle. It took quite a while before I could come up with a solution to this problem. To solve it, I had to investigate how the publication was assembled. The Shakespeare Sonnets is a standard quarto print, with print signatures as seen here on the sheet where the ordered triangle is located. The print signatures are printed at the bottom of pages. 4 pages were set in one go as a typeset, and a sheet included all 4 on one side. On the other side there were 4 other pages printed later. The sheet was then folded twice and then cut as you see here, in order to get the text to begin on the next page in correct order. Now let's look at instructions in the sonnets again. These vague possible instructions are indeed very hard to interpret, but it seems as if a scale of praise works under the hand when advanced over the vacant leaves. As I saw a clear problem with colliding ordered triangle lines in a sonnet form, I investigated the option of using separate collections for each side of the sheet. One collection for the 37-degree ordered triangle angle, and another for the 53 and 90-degree angle side. But what different methods can be used to collect in this way? There are only a few possible ways to do this. A. I could use the definition of verso and recto to collect and count all verso pages as separate from the recto pages. Verso means left side and recto right. In a publication, verso pages always appear on the left side in the finished book and recto to the right. But if I need to dismount the publication and lay the vacant leaves on the table, this would mean that each half leaf has 4 pages on it, 2 on each side as the quarter sheet had been cut as the image here shows after assembling of the publication. When I collect verso and recto pages in this method, I will need to go in a diagonal fashion between the full quarter sheets as the image shows. This is of course possible, but it does not seem intuitional. Not if the scale of praise should work under you as instructed. When collecting for example verso, we will need to skip the underside of the sheet as this page is recto. Thus the method of collecting does not work under you. B. I could of course also lay all detached leaves on top of each other with the text in the same direction. This would seem intuitive. I would then end up with 4 pages on each side for each pair of half-quarter leaves as seen in image B. The order of the pages are as seen in the image for a full quarter sheet. In this method the foldings will become uneven, and the bunch of 40 half leaves from the 2 publications, Aspley and Wright, would be difficult to handle. There are 20 half-quarter leaves in one publication. C. My final alternative would be the same as method B, but instead of laying the leaves so that the text end up in the same direction and with uneven foldings, I instead follow the folding of the leaves. The 40 half leaves will then fit together nicely and be easy to handle. The page numbers for each side also become more intuitive, with 1, 2 on the left side and 3, 4 on the right. From the instructions in the poetry, it is impossible to know for sure which method of these to use, but the most intuitive would be method C. After a lot of experimentation, I confirmed that this is indeed the right way to do it, following the folding of the leaves. So how was this supposed to be done in the 17th century? A theory would be as follows. 1. Lay all vacant leaves from Aspley and Wright on top of each other with the folding in the same direction. Cut through the folding and place the left pages in one pile and the right pages in another. 2. For each pile of half vacant leaves, put a thin metal form or alike over each sonnet, with the audit lines for that side drawn on the form with hair or metal threads or alike. 3. If a one-dotted O appears on the audit line in a sonnet, mark it with, for example, a circular colored ink stamp around the O. 4. When all about 308 sonnets have been marked, around 154 in each pile, go through the marked sonnets again and measure with a fine ruler the distance to the O from the start of the row. Mark this distance on a paper form of the sonnet frame. 5. When finished, count if a position on the paper form sonnet audio line have exactly 3 one-dotted O's total. If so, this is a valid reference point. A metal or wooden frame using hair from a horse or like, or maybe thin metal threads were possible to construct during the 17th century. With this method it would have been possible to create a frame with the same size as the sonnet and draw the audit lines through it. Then it would be easy to stamp mark dotted O's. When all positions with 3 one-dotted O's are collected, it would be an easy thing to apply them to the audit area. 1. Take the left side paper form where the collected 3 one-dotted O's, if any, are marked out on the audit lines. 2. For each row a valid reference point exists on the paper form, measure out to the same position on both sonnet 4 and 5. If the point hits the audit line in any of these sonnets, then this position represents a one-hole drill rock, a valid reference point. 3. Do the same but with a right side collection for sonnets 15, 16 and 17. These images show the actual forms I used when collecting. I printed them on transparent plastic and then used high-res color prints of the Folio Library Aspley and Wright sonnets pages in natural size. I did the decryption as intended. By using a magnifying glass I marked all one-dotted O's on the pages. Left side in one collection, right side in another. To be on the safe side I collected all one-dotted O's, even such placed outside the audit lines. I was not 100% sure at the time if the O's were located on the lines. After collection, I processed the frames in image software. I stacked them all together on top of each other. I spent a lot of time trying to figure things out, and I used broad methods. The image here is from an earlier stacking attempt where all frames from both sides, plus Lover's Complaint, were stacked on top of each other. But as I found out later, this was not the right method. Only sonnets should be processed, and the left and right side should be separated. After stacking, a computer script found out which positions there were only 3 one-dotted O's. The black blots in the image are all one-dotted O's in the whole 2 publications, Aspley and Wright, on top of each other. In a separation left and right side there are much less O's in the collected frame. Now to the final result of the decryption. What you see here is the result of weeks of painstakingly complicated procedures, working with extant sonnet copies Folger Aspley, Folger Wright and Greenville Aspley. Folger Aspley and Wright was the pair I used for decryption, and Greenville Aspley for cross-checking. Unfortunately, I did not have the resources to use other copies, as high-res digital facsimiles of those were very expensive. I could not use reprints from scans, as I could not know the resolution of the scans. I needed to use digital facsimiles with known resolutions in order to be sure all details were given correctly. It is important to know that I did the decryption the intended way, by printing high-res copies of the pages in original size, and then used a magnifying glass. Some of the blots seem to be natural, created by the printing process. Some are even very faint. Others seem too big or too oddly formed in order to be natural. If we check position A and the two blots in sonnet 99, Aspley and Wright, we see here in the green rectangle marked 1 that the blots are formed as a star, not a dot. The star is slightly different in Aspley and Wright versions, but the same tool could have been used. If we then check the Greenville Aspley above, we find a thick circular blot, not a star. The Folger Aspley and Wright sonnet 99 are the only occurrences of this star-formed blot I have found in the whole publication. It seems artificial. The theory is that they were dotted with a sharp tool, as the O in sonnet 99 in the Folger Aspley and Wright copies did not get a blot naturally by the printing process. But the blot in sonnet 99 in the Greenville version could have been a natural ink blot, and thus no tool was needed. This could be the reason we see a star in Folger Aspley and Wright and a blot in Greenville Aspley. I believe the star form was put in sonnet 99 if no natural blot was present, as a clue. Sonnet 99 has 15 rows, not 14, as told before, and one cannot get the decryption right if not understanding how to attach the collection frame in this sonnet. Also, let's check the last example in position A, the Aspley sonnet 140. You see it here in the purple rectangle marked 2. I place this here even if it's not a valid dot in order to show how the encryptor could have worked. In order for 3 one-dotted O's to appear when adding up any Aspley copy with any write, then one of the versions need to have one one-dotted O and the other 2 for a reference point. It seems as if the encryptor have chosen write to carry 2 one-dotted O's in all 3 reference points, and Aspley 1. In Aspley sonnet 140 the encryptor had been forced to transform an O with a natural 1-dot ink blot into 2 dots to make it a 0 in the binary system. Otherwise the position would get 4 one-dotted O's and thus not be valid. In the Greenville version we see 2 blots of the same size, distinct and clear. One could be the product of ink dirt and the other artificial. In the Folger version we have more chaotic blots, but my guess is that the lower is artificial. There are 2 ways to verify that this decryption is correct, which I will explain in a moment. So, in order to understand if this method is workable from an encryptor's point of view, I constructed a theory of how the sonnets were encrypted. A small team of encryptors would have been needed only, and the process would have been much faster than what is needed for decryption. The following step-by-step method could have been used. 1. Use a magnifying glass. Check all O's in the sonnets Aspley and Wright that are located along the lines of the audit triangle, and that has at least 3 O's in the same position. Check each side of the printed sheet separately, as seen in the image here beside. Only some sonnets are needed to check. 2. Count all one-dotted O's at each position you find in step 1. These dots are created naturally by the printing process. It is important to separate the count of left Aspley, right Aspley, left right and right right. 4 counts. 3. Use a sharp-pointed tool dipped in ink. 4. For each valid reference point, decide which publication should have 2 one-dotted O's, Aspley or Wright. The other publication will get 1 one-dotted O. This will force the decryptor to use both versions of the publication. The encryption will thus result in a 2 one-dotted O's for each reference point position. 5. If more than 2 one-dotted O's exist at the position of a valid reference point, then add a dot to the redundant 1-dotted O's and transform them into 2-dotted O's. Thus they become nulls. This will keep the 2-1 encryption. 6. If less than 2 1-dotted O's exist at the position of a valid reference point, then add a dot to the amount of no dotted O's you need and transform them into 1-dotted O's. Thus they become valid. This will keep the 2-1 encryption. How to transform an accidental 3 1-dotted O position. 7. If 2 1 or 1 2 1-dotted O's exist, created by the printing process alone at the position of an invalid reference point. Then add a dot to no dotted O's in this position, or add a dot to one or several of the one dotted O's. This will break the 2:1 or 1:2 ratio. The position becomes null. A team would with this method be able to encrypt many copies of the sonnets fast, regardless of the print dirt situation. The decryption and the theory of encryption brings us to the will cryptogram in sonnet 135 and 136. This cryptogram seems to give a message that we need to bring many wills, as the blots in the O's are sometimes very faint, and one needs to look very carefully in order to get it right. We could decrypt another pair of ASCII right in order to confirm our result. The more pairs we decrypt, the more sure we can be on a correct decryption. Does the encryptor want us to bring many copies of the Shakespeare sonnets 1609 to Oak Island, so that we can confirm the decryption? Does he intend the decryptor to use a team working in parallel, checking blots in many pairs of the publication? It is my strong belief that this is the intended way of verification, decrypting many pairs of the publication. A. The more sonnet pairs ASCII and right we decrypt, the more secure we can be on a correct decryption. For decryption and verification in the 17th century, you will need a staff of many decryptors working in parallel. B. The decryption can also be verified with the painting Shepherds of Arcadia, 1638 by Nicolas Poussin, which I will show in a moment. This painting was probably created for verification purposes. It is possible maps are cloaked in other works as well. Now let's collect our work and try to assemble it. We suspect we have 3 separate works that include information to be used with Oak Island: the Northumberland manuscript, the Shakespeare sonnets, and the painting Shepherds of Arcadia. The solution to the Northumberland manuscript cover sheet alignment cryptogram is shown here. The pointer line, the blue line seen here, is as we concluded a bit vague in instructions, but the rest is more secure. The pointer line and the baseline intersect in the far distance. As explained in the first lecture, the 2, 3, 4, 5 triangles from the Northumberland manuscript is confirmed by the same setup on the Shepherds of Arcadia. It is simply too unbelievable this is the work of coincidence. In both cases we can argue that these formations are intended structures. The Northumberland manuscript can be approached with statistics, aligning scribble and 37, 53 and 90-degree angles between alignments. The Shepherds can be approached by the fact that the diagonal line of the smaller triangle is actually painted on the painting, and the chance that angles on the larger triangle ends the way they do, lining up with the eyes and staff lines, are convincing. It is unlikely these features are created without thought. Actually, the 2 triangles with one inside the other do in fact stabilize each other. This is true also on the Northumberland manuscript. As points are not exact on neither of these 2 works, the triangles with known angles do stabilize the geometric construction. After the enormous work of decrypting the Shakespeare sonnets, I got 3 reference points I suspected represent drilled rocks on Oak Island. In order to be very sure of the positions of these points, I would need to decrypt other pairs of ASCII and right. But if overlaying the Shakespeare sonnets ordered 3-4-5 triangle with reference points over the Shepherds of Arcadia's larger triangle, the reference points hit exactly on 3 crossings of the staff line seen here. This correlation is too exact to be a coincidence, especially in combination with the correlation of the Northumberland manuscript and the Shakespeare sonnets. The Northumberland manuscript directed us to the Shakespeare sonnets. It is very important to understand that I did not, and I repeat did not, imagine that these 3 crossings on the painting marked reference points, and then created rules to decrypt the sonnets in such a way that I got the same 3 points from the sonnets. Such method of creating rules for the sonnets would have been a much greater task than what I in fact have done. You would have had to come up with a rule, try it by looking through over 4,000 lines of text in both versions of the sonnets, just to see if it matched this painting. No, I collected vague hints, interpreted them as instructions, and used the instructions on the Sonnet publication without looking at this painting. I found the match first after decryption. So, if we have extracted geometric forms from both the Northumberland manuscript cover sheet and the Shakespeare sonnets, and these geometric forms seem to be verified by decrypting the Shepherds of Arcadia, then maybe we can confirm the existence of the pointer line we got when reading instructions in Sonnet 145. This interpretation was very interesting but could be labelled a bit vague, as we jumped from the sonnets back to the Northumberland manuscript. If we overlay this pointer line on the painting, in both the original smaller triangle position and the transformation to the larger triangle, we get interesting results. In the larger triangle, the pointer line follows the arm of the lowest shepherd, seen here in box 1. It then extends upwards and aligns with the branch on the tree in the background in box 2. I can find no other objects in the painting that align with this overlay. This could of course be a complete coincidence, but it is nevertheless interesting. If we place the pointer line on the smaller triangle, as it is positioned on the Northumberland manuscript, we get something even more interesting. The line extends from the leftmost shepherd's eye in box 3, goes downwards and hit the eye of the lowest shepherd in 4. When looking at the cryptogram after this overlay, we see that all 6 eyes in the image have been used to carry information. 3 of the eyes to define the larger 3-4-5 triangle, 2 of the eyes to define the pointer line, and 1 eye to mark the staff line that sets the position of reference point C. This could all be coincidence, of course, but it's easy to see that the chance for coincidence is a bit small. If these cryptogram structures on the painting is intended, then it's probable they were not created to be understood without other works confirming the structures. It is simply too abstract. I believe the painting is one of several man-made works that were created for confirmation purposes, so that maps in other works could be understood. More on this thought in the grand plan section further down. So the next obvious question would be, how do we attach the reference points to the geometric form? In theory, we have 3 ways of doing this when using the Northumberland manuscript geometry. The methods are seen here. We have 2 or maybe 3 3-4-5 triangles if counting the mirrored version of the smaller triangle, so the reference points can be attached to any of these triangles. But in the Shepherds of Arcadia, the reference points were confirmed by staff lines when placing them in the larger triangle. So is this the right way of attaching them? I will answer this question if we initiate a collaboration. Although I have been able to use the decrypted geometric map in order to find the X-marked boulder, the work involved in order to overlay the map correctly and find it was enormous and very complicated. It took me a whole year. In order to pinpoint the set of positions on the mainland I investigated in 2014, I needed to use surveys very hard to find together with letters describing drilled rocks in text. I also needed to use trigonometry calculations in order to achieve understanding of drilled rock positions in relation to described landmarks on Oak Island. On top of this, I needed to analyze the rough-sized areas pointed at in the different map overlays in order to figure out the most likely positions to investigate at each location. The information at hand did not produce exact positioning. Also, I needed extreme luck in order to actually find the X mark. As I have told before, I found it on the photograph I took at random. In addition to the X mark and disturbed earth underneath it containing strong GPR reflections, there are more information showing I have found the right place. I will present this additional information if we initiate collaboration and have started a company. Thank you. Let's get back to the Kempton symbol sequence for a moment. The source of these symbols are from 1949, and the English substitutive decipherment seemed to be ridiculous. The source letter also described the top of the money pit design in more detail than any other source, with some details being different than what can be found in newspaper articles and prospectuses. In the lecture on my website, I have shown that the Kempton sequence very likely is an intended dual cipher, due to the fact that it is extremely hard to create a tabula recta, or a cipher disk, in different designs leading to different messages using the same sequence of symbols in a polyalphabetic cipher. This difficulty is of course dependent on using the same set of rules, but as the rules Dr. Willem uses directly copied from Porter's book, then the claim for a dual cipher should be taken seriously. In the grand plan theory further down, I will explain my theory on a motive for creating a dual cipher in this context. And a most interesting thing is that we seem to be able to create the upper row of the tabula recta used for the Kempton symbols with the help of the dotted sonnets in the Shakespeare Sonnets Quarto 1609. This might seem like a mad idea, but let me explain. First, let's start with some vague hints. In Sonnet 2 the poem starts with "When 40 winters shall besiege thy brow, and dig deep trenches in thy beauty's field." This could, with a little bit of imagination, be interpreted as, when you see 40 difficult things, the 40 inscribed stone symbols, and you have dug 80 or 90 feet and are about to dig further. Vague, but let's continue. In Sonnet 133 we have a peculiar parallel. Unexpectedly we have in the middle of the sonnet a tournament twice threefold, thus to be crossed. If we combine this expression with the number of the sonnet 133, we can interpret 133, one torment of 3 appearing 3 times. This torment should be crossed. This could be interpreted as describing the false operating symbol in the Kempton sequence. If we do not change this symbol, we cannot get the last part of the polyalphabetic cipher message right. It needs to be changed into 2 symbols of 2 dots each. Then if we jump back to Oak Island itself, we have fragments of a large boulder that once was placed on the beach of Oak Island. This boulder was full of symbols, but dynamited during the 19th century in order to look for treasure underneath it. This fragment was found and photographed by Gilbert Hedden in 1939. On the fragment we find H, eta. This letter is used in many places in the sonnets as a pointer for cloaked structures. The ordered triangle use it, and also the pointer from dedication to Sonnet 145. The circle with the dot inside is of course the chemical sign for sun and gold, or an O with an ink blot inside. This is a major clue to extract reference points in the sonnets. Between these symbols we find 2 dots plus 2 dots. This is the corrected symbol for the Kempton symbol sequence. The plus is needed in order not to confuse the 2 symbols with one symbol of 4 dots. So now we seem to have some kind of connection between a rock found on Oak Island and steganography in the Shakespeare sonnets. We also seem to have a connection to Dr. Willem's break attempt of the Kempton symbol sequence. Now let's approach the dotted sonnets themselves. We need to start with Sonnet 122. This sonnet has a strange doubling of T and a comma sign in the beginning, and mention the word tables, rank, characters, tallies, and score in some places. Could this be a hint pointing towards a tabula recta? A tabula recta is a table used to decipher or break a polyalphabetic cipher. Let's listen to the sonnet.
Thy gift, thy tables, are within my brain full charactered with a lasting memory, which shall above that idle rank remain beyond all date, even to eternity. Or, at the least, so long as brain and heart have faculty by nature to subsist, till each to raised oblivion yield his part, of thee, thy record never can be missed. That poor retention could not so much hold, nor need I tallies thy dear love to score, therefore to give them from me was I bold, to trust those tables that receive thee more. To keep an adjunct to remember thee were to import forgetfulness in me.
Let's assume this sonnet describes a tabula recta. A tabula recta was used by Ross Willem in his break attempt of the Kempton sequence of symbols, though Dr. Willem turned the table on its side. An upright tabula recta is depicted in Porter's book De Furtivis Literarum Notis as an alternative to a cipher disk. Let's try to interpret the sonnet in the context of a polyalphabetic cipher. Thy gift, thy tables, are within my brain. The TT and 2 comma signs give hints towards doubling. Use the tabula recta with this cipher. Full charactered with lasting memory. Use the full alphabet as it was constructed during the creation of this cipher in early 17th century, which shall above that idle fixed rank row remain. The full alphabet shall be placed on the upper row. Nor need I tallies thy dear love to score. Use markers, tallies on the tabula recta to experiment with symbol positions when you break the cipher. To trust those tables that receive thee more, you need to add something to the tabula recta. To keep an adjunct to remember thee, the tabula recta must receive an addition. Where to import forgetfulness in me, the addition is forgotten, which could mean not told. This is of course a free interpretation, but it seems we have a handful of words that can be connected with the break attempt of a cipher using a table. If we interpret the keep an adjunct and receive the more as instructions to add one thing to the table, then we can construct an interesting connection. Now let's look at the other sonnets. We have 2 other sonnets in the Sonnets of Numerology sequence that are dotted, number 9 and 18. Both of these have the correct gematria value character as initial character in the poem. But the catchword 10 does not have any initial character, of course. As sonnet 10 itself on the next page is not dotted, then it is probable the instruction follows the catchword, not the sonnet 10 itself. How can we interpret the structure of dotted sonnet numbers? What does the author mean by full charactered with lasting memory? Does he mean we need to look at the full alphabet as it was constructed during the printing of the sonnets in 1609? It is interesting that we have the number 22 in sonnet number 122. The English alphabet at the time had 24 characters, but the Italian had 21 and sometimes 20. Porta, the inventor of the cipher method used for the polyalphabetic section of the Kempton symbols, was Italian. If the expression hints towards the number of characters we need to put on the idle rank, the upper row, including an adjunct, a company, then the author could mean the Italian alphabet of 21 characters plus an adjunct to get 22 characters. So the number of the sonnet 122 could be interpreted as fully charactered 21 plus 1 equals 22. This is of course using our imagination a bit, but as we have seen in the rest of the sonnets, this publication frequently connects the numbering of the sonnets with the content of the poems in it. So let's assume we need to put the Italian alphabet plus an adjunct, 22 characters total, on the upper row. When we look at the gematria value of the English 17th century alphabet, we find that number 9, I, and number 18, S, is correct. But when using the Italian alphabet, the 9, I, is correct. But as we have no K, number 18 is T, not S as in the sonnet 18's initial character. So what is wrong? Should we use the English alphabet and not Italian? Or have we missed something? Let's look at the poem again. We have the word tables 2 times and also fully charactered. Then we have those tables that receive the more and to keep an adjunct. Should we interpret this as if the table needed 1 slot more, an adjunct? If we look at the definition of the word adjunct, we find something attached to another in a dependent or subordinate position. Is this meaning of the word adjunct together with the fact that we have doubling of T and a comma sign in the beginning of sonnet 122, hinting towards doubling of a character in the table? If so, we have an empty slot at number 10, if interpreting the dotted catchword as empty. If we double the I, as seen here in slot number 10, and thus shift the alphabet up 1 step to get 22 characters, then the S become number 18, the correct gematria value for the initial character in sonnet 18. Now to something very interesting. If we interpret the dotted sonnets in this way, then we end up with the same upper row tabula recta as Dr. Willem extracted in his break attempt of the Kempton symbols. The only difference is G instead of the double I in slot 10, and Y instead of Z in slot 22. This difference does not affect the message outcome, as I can be used as G if thinking like an Elizabethan Englishman, and Z and I is not used in the Spanish message. Also, Dr. Willem understood a simplified alphabet was used, but somehow I did not notice that he extracted the Italian alphabet plus a G. If this is an intended feature, then the correct spelling of the Spanish message in the only place G occurs should be mío, not mijo. To a Spanish person this would make no sense, but to an English encipherer using the English alphabet to cloak a message in the Spanish language, this would be acceptable. Analysis of the dotted sonnets. This method of interpreting the dotted sonnets as instructions to build the upper row of a tabula recta could of course be criticized. I could be accused of using my imagination a bit too much, backtracking from Dr. Willem's break attempt and apply the setup to the dotted sonnets. B. But the words used in sonnet 122 are indeed used in polyalphabetic cipher terminology. The sonnet holds many of them: tables, fully charactered, idle rank, tallies, score, etc. C. The phrase in sonnet 133, "a torment tries threefold, thus to be crossed," gives a striking parallel to the false operating symbol in Dr. Willem's break attempt of the Kempton symbols. D. The photograph of the bowler with symbols on the Oak Island surface that shows two symbols used in the sonnets, eta and the circle with the dot, also show 2 dots plus 2 dots. This is the corrected operating symbol in Dr. Willem's break attempt. I will now explain my theory of why I've been able to extract a geometric map to be used with Oak Island from work seemingly unrelated to the island. This theory includes the full idea and plan for the Oak Island project. First, some background information. Kempton's full letter, which seems to be told from the perspective of an on-site worker, include details not told anywhere else. An iron cask is claimed to have been found at 60 feet in the money pit, stolen during the night and then transported off the island. We also have reports from other sources saying gold chains were found in the pit. And of course we have a piece of paper with ink found in the cement chamber at 153 feet. In the macro perspective, Francis Bacon played a leading role in establishing the British colonies in North America, especially in Virginia, the Carolinas and Newfoundland in northeastern Canada. His government report on the Virginia colony was submitted in 1609. In 1610, Bacon and his associates received a charter from the king to lead the colonization of Newfoundland. Some scholars believe he was largely responsible for the drafting, in 1609 and 1612, of 2 charters of government for the Virginia colony. Virginia and Newfoundland are located above and below Arcadia, Nova Scotia. In my theory, the motive for the Oak Island project was to build an automatic protection complex that protects something Bacon and his people felt they could not protect in their own time. This something needed to be found again by future people that would know how to handle and protect it. If the motive was to store away religious artifacts used by early Jews, then these could be made of gold. Vessels used in tabernacles and the early temple were made of gold. If unworthy seekers found these items, they would melt them down and sell the gold. Thus they needed to make sure only people with education, morale, sense of responsibility, and religious motives would find the items in the future. The auto-protected storage must A. Ensure only people with the right motive and resources enough to protect the treasure actually do discover it. B. Ensure a long time have passed before the storage is found and the items retrieved by the worthy. This would make sure society, morale and knowledge had developed. C. The storage and protective system thus need to physically be able to endure time. D. The protective system can never be forgotten about. It needs to be fresh in people's memory until solved and the items retrieved. Bacon was a futurist. He felt the tyrant times he lived in was an abomination. The farmer talks of 100 years, and this was possibly the minimum time delay Bacon had in mind. Society needed to develop first, and Bacon put hope in the new world. America would be the new, better society run by people of esoteric knowledge and higher morale. Bacon was active in colonizing America for this purpose. So back to my theory. After Philip Howard's arrest and death in the Tower for Catholic beliefs, Bacon persuaded his son, the young Thomas Howard, Earl of Arundel, to finance a project that would safeguard the inherited items for the future. The group that guarded the artifacts could no longer feel safe. If they were arrested and killed, then the location of the artifacts would be forgotten and protection would be lost. As Bacon, during his time at the French court in his youth, showed interest and strong talent in poetry, he began to think like the maverick he was, outside the box. The Oak Island construction and the cryptographic system itself had the attributes of a work of art. I believe Bacon was equipped with strong artistic intelligence, with the talent to come up with solutions other people will never think of. His group first approached Axiom C and D. How do we make sure this project is never forgotten about? And how do we create it so that it is able to physically endure time? There are only a handful of things created by man that future people will save and protect indefinitely. 2 of these are works of high-quality art and physical constructions of significance. The Oak Island project includes both of these. Poetry in plays of high quality, in contrast to paintings and sculptures, have the additional advantage that they can be copied up in large numbers. This will increase the chance some of them will still exist in the far future. As Bacon was into poetry, he decided to use his talent for the project. In secret he assembled a group of good pens and made a secret pact with an actor, William Shakespeare. He probably chose William partly due to his last name being similar to the spear of Pallas Athene. The plan was for the group to create written art of a quality one single man could never produce himself, however talented, and then have William to claim he wrote it all single-handedly. This would make William a superhero author in his own time. The secret group then produced publications of William's poetry and filled these with cloaked information to be used with the Oak Island protection system that leads to the vault. They then knew the publication would be saved and read by many generations for hundreds of years in the future. Information to get to the storage would thus persist. The encrypted poetry in place had 2 functions. One was of course to carry information on how to get to the vault. Another was to work as a bait. If the reason for the Oak Island and Shakespeare projects was to store something a small group had guarded, then no one knows about these items but the group. Thus, the project needed a bait, a reason for future people to go through with the project of decrypting maps and go search for the vault. The group used the original manuscripts of Shakespeare signed by the true authors as this bait, and placed these in the vault together with the true reason for the project. The plan was to first scout an area in North America they knew would not be colonized until a long time later. They needed 2 positions. One would work as the location of the vault, and the other as the location of the false impenetrable treasure keep, the beacon. This place would also hold a primary and secondary map. The functions of the maps would be to enable a worthy seeker to go from the island to the vault. The first thing to do after choosing the area was to collect the basic data for the maps. For this they needed to use the only thing available at the time with enough precision, triangulation. Navigation using the stars did not have enough precision. For triangulation to work, they needed to build towers with bonfires on top, and then use a navigational instrument like a David's quadrant, a backstaff, or something specially made to measure the angles between fires. They needed at least 3 towers, with one on spot X and another on the island. They also needed to measure the real distance between 2 towers for the triangulation to work. This first measurement could have been done with a smaller triangulation, or with ropes, chains, or like. They also needed a workforce to build the towers. As the group probably consisted of English gentlemen and/or noblemen, it would be a dangerous thing to use an English workforce. It is obvious the enterprise was very secret. If using English minors, they faced the risk of being recognized. The workforce would of course also understand the language spoken by the projecteers, English. In European society at the time, only 5% could read and write, and only a handful of these had the time and education enough for this project. People with this kind of background was known in the society they lived in. They traveled on horses, wagons, and had expensive clothes. So to neutralize the risk, the projecteers went to Spain, the arch-enemy of England, to hire workforce. To reduce risk as much as possible, they only hired very strong men. In this way they needed fewer miners. This could be the reason a shoe of size 14 had been found on Rock Island, and only Spanish artifacts had been found. Spanish miners would not recognize the projecteers and could not understand English, but the projecteers spoke Spanish as well as English. They hired the workforce and took them on a ship to the island. The workers had no idea where they were and were told a fake story on why towers needed to be built. They were paid to keep silent. Maybe they used 3 different teams with no relation to each other, one for each tower. A second workforce with no relation to the first then built the money pit and the artificial swamp. No worker had any idea what they were really producing. 2 boxes with cryptographic maps were produced beforehand, sealed and then lowered into the money pit and the swamp, with just a few people present. As the money pit functioned as a beacon for the unworthy to discover as well as a map keep, they thought it a bit risky to put all the information needed in order to solve the map in the money pit box on the island. They therefore created a dependence on a second encrypted object that the decryptor needed to bring to the island in many copies to feel sure about the decryption, the Shakespeare sonnets. In this way they knew no one could get to the vault without understanding the connection from the box content to the external item, the sonnet's publication. To be on the safe side, they also hid a backup copy of the money pit map, the Northumberland manuscript, in the library cellar of the financier of the project, Thomas Howard, Earl of Arundel. Or, the manuscript was stored in Francis Bacon's childhood home York House right next door, but was moved to the mansion at some time in the past. After construction, they burned all plans and traces from production and paid all workers to keep silent. Then they gave the Shakespeare sonnet publication to a small group of friends to read as poetry. They had now safeguarded the artifacts in the vault for future generations to find, and they could live without fear of being imprisoned or killed. They produced new encrypted works after the project was finished, the first folio in 1623, and also paintings like the Shepherds of Arcadia in 1638. They also printed the Rosicrucian manifestos to ignite an intellectual revolution and direct people to search for the testing facility island. There might be more encrypted items produced we don't know about yet. The plan for the discovery worked as follows. While settlements in America expanded and society there developed, people of esoteric training discovered hint-like cryptographic structures in publications, paintings and other works. They could not understand the meaning of these structures, as the island was not yet discovered, but they protected the works and labeled them interesting. After maybe 100 years, settlements had expanded into Arcadia, and farmers or fishermen discovered the money pit. In my theory, the top section of the money pit before the inscribed stone included some hints or clues to Shakespeare a bit hard to understand. These hints could have been in the form of short poetic phrases on jewelry or something similar, vague hints. This should have been needed in order to connect the site to the works of the Shakespeare sonnets. The sonnets were printed 1609 and the first folio 1623. It is not at all sure the first folio was planned when they designed the Rock Island system. It could have been a later add-on to the cryptographic prints. But in order to get past the inscribed stone, one needed to decipher the polyalphabetic section of the symbols. You need to break the cipher with the help of clues placed on the island's surface, like the boulder with symbols placed on the beach. Breaking this kind of cipher is very hard, so this works as an intelligent and educational test. The dotted sonnets help as it gives the upper row of the tabula recta. This knowledge would shorten the time to break the cipher. The absurd message 40 feet below 2 million pounds are buried is a decoy message, a lie. It is the lie that activates one of the functions of the money pit, to work as a beacon. The pit would be found first by simple settlers like fishermen or farmers. This would by Bacon be defined as unworthy people. The island would then need to attract enormous attention, creating rumors that spread over the world. Thus the constructors needed to make sure diggers believed the pit was a treasure keep and not a mine, a weapon storage facility or alike. The ingenious water trap system in combination with the simple substitution, 40 feet etc., would look as an impenetrable treasure keep in the eyes of the greedy, and rumors would spread with endless efforts of trying to get past those traps. This is exactly how the pit have worked so far. The unworthy would not understand the symbols and rock formations on the surface of the island. If one do not see that the inscribed stone symbols is a polyalphabetic cipher as well, one would feel satisfied with the English substitution decipherment and believe one has deciphered the symbols fully. The large stone, as it is a heavy piece, will then lay around the area waiting for worthy people trained in cryptography, and thus esoteric training to notice the possibility of a polyalphabetic cipher, a knowledge and intelligence test. When Arcadia becomes more populated and society develops to a better place based on scientific thinking and high morale, people will start to notice things. Objects on the surface of the island that seem to be of esoteric nature, like the equilateral triangle and symbols, and objects found in the pit would be connected to encrypted information in works of art like the Shakespeare publications. When this happens, the discovery process can begin. Before this stage, a succession of unworthy, greedy people would have tried to get down the pit. They have filled an important function, keeping the memory of the project alive by spreading rumors about the strange island. The discovery process will then follow a more or less straightforward path. A. People of esoteric training that has resources recognize the island as important. They take over the island from settlers. B. As they found cryptographic structures elsewhere connected to the island, they bring these encrypted works to the island. C. As they are trained in cryptography, they decipher the inscribed stone and get the true message in Spanish with the help of the sonnets. D. If the money pit is not destroyed, they bring ships with corn and fill the cave-in and South Shore pit to stop the traps. E. If the pit is destroyed, they search the island, find the Tree of Life structure and begin to empty the swamp and dig at Mercy. F. They discover encrypted documents in the money pit cement chamber, or if this is destroyed, in the Mercy box. G. In the money pit cement chamber, they find a cryptographic map that you need information from outside the island, the sonnets, in order to solve to increase security. This map uses drilled rocks as reference points. You need to bring the sonnets in many copies in order to make sure you decrypt the map correctly. H. In the Mercy box chamber, they find another cryptographic map which they possibly need external information in order to solve, or not. The Tree of Life stones are probably used as reference points for this map. I. Both maps lead to the same position outside the island by using two pointer lines that cross each other in the distance. The pointer lines together with the geometric form must be placed on the Oak Island reference points. G. In this way the real vault is completely secure from any type of unworthy activity on the island itself. K. The real vault holds the reason for the Oak Island and Shakespeare projects, religious artifacts such as the menorah. The menorah is made of pure gold, and in order to save it from being melted down by greedy men, they created this project. L. The project also included bait for future generations, the Shakespeare manuscripts and possibly also descriptions of the Shakespeare and Oak Island projects as such. This content forms a reason for future people to go look for this treasure, as future people don't know anything about the present existence of the menorah. But future people very likely would know Shakespeare, as Shakespeare's work were tailor-made by a team to be the best playwright and poetry ever written. M. What I have discovered is a cryptographic connection between the Northumberland manuscript and Oak Island. N. The Northumberland manuscript is most likely a backup copy of the money pit cement chamber documents stored in the cellar of the financier of the project, Thomas Howard, the Earl of Arundel.